So here we have the distributive property and in combining like terms. So for this first one, I am distributing -2 to 7 and -2 to -n. So you do need to keep in mind that it is a -n or a -1. So we do know that -2 times 7 is -14. And this ends up being plus 2n plus 4. And then we can go ahead and combine and say that this is 2n minus 10. And again, I'm going to put it, there's going to be a neat little video that explains this on that same cool website. So here, this one looks kind of difficult. I have a -4p, and then I have a subtraction sign, it looks like, 1 minus 6p. Well, again, there is an invisible 1 hanging out with the subtraction sign. So what I'm actually distributing is I'm multiplying -1 times 1 and -1 again times -6p. So right now it's going to say -4p. Of course, these boxes have that funky. -4p plus 1 plus 6p. And since that's a negative and a positive, it turns into 2p plus 1. And the 1 cannot be combined with anything because it's a constant. Up here, the +4 and the -14 could be combined because they were both constants, and that was all that could be combined for that one. But that is, again, having the distributive property in it. So here I want to add these two expressions at first. So I'm going to basically do -4m minus n plus, and I'm going to put this in parentheses, 7n minus 2, just because I'm going to do it in the next problem. I'm basically distributing this positive, and it doesn't change anything. So it just makes it stay plus 7n. So here I am. I have a -4m, and I have a -n, a +7n, and a -2. So these two guys right here are the only two that can be combined. And so I have a -1n plus a 7n. So this equals -4m plus 6n minus 2 is what that simplifies to be. Now for this question, it wants us to find the difference of these two expressions. So I'm going to start typing. Okay, so I have -4m minus n minus 7n minus 2. Now in this case, I'm distributing a negative to these two terms. So this actually becomes a -7n and a +2 once I have distributed that negative to make those parentheses go away. So now I can combine like terms. The only two that I have that are alike are the ones that have the n as their variable. And so I get -4m minus 8n minus or plus 2 because we had to distribute that negative sign. So this is another example of that that we can do. So here I have 3b minus 5. So I'm going to do I'm going to type it out. 3b minus 5 plus -6b minus 8. Please note again that this did start with a set of parentheses around the second expression, but I'm distributing that positive sign did not change any of these values. So 3b minus 6b, I'm just going to ignore these two constants for a second. That equals -3b, and then I have a -5 and a -8, which equals -13. And so, like almost magically, because this is -13, when I plop it beside the -3b, it becomes a subtraction problem. So this is the simplified version. So down here, 3b minus 5 minus negative 6b minus 8 in parentheses. Here I'm distributing that negative 1 again. So this becomes the 3b subtract 5 is going to stay the same. Then it's going to be plus 6b because this two negatives make a positive, plus 8 because again the two negatives turn into a positive. So here I end up with 3b plus 6b, which gives me 9b, and then a negative 5 and a positive 8 leaves me with positive 3. Now for some of these guys, it might be best if you would come over here and do that t-chart. And even from this right here, you can write all of your terms and constants in the t-chart. And I would probably use a separate one for all the ones that have b's, and then another t-chart for the ones that have just the constants. So that's just a suggestion if you're having a difficult time. So again, let's try these on your own. So magically the answers have appeared. When I distribute this negative 1, this becomes a plus 3y. And this becomes a plus 4. That's how we get to 10. And again, I'm distributing this negative. I gave you 3 of those because it gets kind of confusing. So here, again, I end up with a negative 4 and a positive 4. So this is just negative 5c. You're probably not going to see it say plus 0. And this one is negative b minus 16. This turns into a positive b, leaving us with one negative. Negative 8 minus 8 is 16. So again, guys, I am here at thegraspableMath.com in the Canvas function this now again, and I'm going to put in the last math expression, negative 2b minus, and again, I'm just typing this using the keys on my keyboard. You can use the buttons provided in the function. So I've typed in that last example, negative 2b minus, oops, I forgot about a negative right here. So let's go ahead and do that. So in this one, we've discussed already that we have to distribute first before we can start evaluating this question. The cool thing about the Graspable website is if I just click on this subtraction sign, it distributed for me. So let's look at that again. So basically I'm distributing this negative 1. I know there's not a 1 hanging out with it, but we've talked about that. So we're distributing negative 1 times the negative 1 hanging out with this b. So it becomes positive b. Negative 1 times positive 8 becomes negative 8. So now there we are. So it distributed it for us. We do need to realize that we want to move the terms. So again, I want to click on that plus sign to move the term. I'm going to stick it over here with the negative 2b, and then I'm going to move this 8, that's the constant, so that wonderfully long and insane looking question simplifies to be negative b minus 16. So again, just thought this was a cool tool to show you guys. It is a tool, so do not use it to get the answers. Use it to check your answers or understand. I'm also going to show you the first one that we did with distributive property pretty quickly. So if I type in negative 7, not negative 7, negative 2, parentheses, 7 minus n, in parentheses, plus 4. Now this is what it appears on our paper and in the example. When I push done here, this website or this application realizes that this negative really isn't stuck to that 2. This is actually a negative 1 times this 2. So if I click on that first, it just brings that in and kind of simplifies that first step. So now I can take the 2 and multiply it by everything inside the parentheses. And then also I can click on that -1 and it multiplies it by everything in the parentheses. Now I can bring this guy over here. And again, we really want this to be in the front of the other, but apparently this it wants it to be, we want it to be 2n minus 10 to be in standard form. So one for the road is about perimeter. How do we find perimeter of a rectangle? Well, we find the perimeter of a rectangle by finding the area of all of the sides, right? So if this side is 3x plus 4, this side right here is also 3x plus 4. And this side over here, if the right side is 2x minus 1, this right here is also 2x minus 1. So to find the perimeter of this, we just are going to add up all of these expressions to see what we get. So we're going to collect like terms. So basically here I'm doing 3x plus 3x, which is 6x. 2x plus 2x is 4x, and 6x plus 4x is 10x. So then I have 4 plus 4, which is 8, minus 1 goes back to 7. Subtract 1 again goes back to 6, but it was a positive 6, so it's going to still be a plus 6. So here again, the perimeter is 10x plus 6, because to find perimeter, we added up all the sides, and even though the sides were represented with expressions, all we did was collect like terms to get that answer. So I hope this helped you a little bit with combining like terms. And tomorrow we will be talking about factoring expressions.